I mean, this is an example of what in our community we call large research infrastructure. So infrastructure where the multidisciplinarity is important in order to focus on a particular objective, or more than one. And so there are what they are called the big science LRI, like the space or the CERN, for instance. But there are also the library or the ships, the collection, and of course the neutron and synchrotron radiation. So very simply, you have essentially a way of creating this neutron that you can imagine that is a very expensive tool. So one has to use it, you know, when really all the other tools are not useful enough. And just to give an example of the number of instrumentation and variety, I just here in one slide put down the number of instruments at ISIS, the number of researchers a year from all over the world, and just to say that thanks to the investment of the Research Council, Italians are the second user of ISIS in the world, after the British, of course, and the Americans, which are not European yet. And then we have the different variety of instrumentation focused on the investigation of matter at the molecular level. And this is, just to give you an idea, this is a survey of the European community which tells you the use of different tools in the cultural heritage. And of course, synchrotron or neutrons being infrastructure obviously are used little because they are, as I said, expensive. To give you an idea of how much this research is cost, one day at ISIS, given through peer review system, cost about £18,000 per day. So, I mean, scientists have to be very careful in using this instrumentation. So let's go to the example. So what is the kind of information that this tool, these techniques can give? They can give answer to elemental composition, to the way some cultural heritage object has been made over the past, provenance, conservation, restoration information, and can tell you whether a sample can be genuine or fake. So the only example I will give you is about the radiography and tomography, because this, I think, is the most impressive and easy to show. So the principle is very simple. It's based on attenuation, like the radiography of X-ray that everybody has experienced at the doctor's office. One send a neutron beam on an object and record essentially the picture behind that. And of course, the difference compared to X-ray, which is a technique more familiar to you, is that they see different things. Of course, the importance of neutron is that neutron is non-destructive of the sample, and of course is it goes inside the object, as X-ray doesn't, unless of using very strong X-ray. So they are complementary, and this is an important point. They're not alternative. They are complementary. They can give different results because neutron interact weakly with matter. X-ray interacts strongly with matter. So they see X-ray cannot see hydrogen, for instance. Neutron can see all the elements independently on the electrons. What is tomography? Tomography is when you move the sample and you take a lot of radiography picture and then you reconstruct a tomography. Of course, tomography is important because if you want to go and look inside, like in this case, a nail from a Roman ship which was embedded in calcium dress, you can, without destroying the vessel, you can see what is inside. This is very important for the archaeology. Or you can couple the radiography, the tomography, and the diffraction, and a combined use of these three techniques can tell you more. For instance, this is an example of a tomography on some ceramics from Sicily, where the researcher could show what the composition and the arrangement of the atoms, and that gave some additional information on the making technique. Or in this recent work on Villa Adriana marble, where the marble has been analyzed by the 3 combined techniques, and we have been able to see the different weight of the components, which tells you also, give you also the information on the provenance of the marbles, because the Roman at that time used to also to use marble from different countries. And these are unique information, which are not, of course, they have to seen, in my opinion, together with other information that one can obtain from other techniques, but they can feel. Most recently, we, in this project, which has been funded by CNR and by the European community, we have been able to show that given some black boxes made on by archaeology, so without telling us what was inside, by the combined use of these techniques, we were able to reconstruct what they had put inside. I mean, they wanted to check whether we were really able to look at what they wanted. So I think I've been in the 50 minutes, yes. And I will leave you. Well, thank you very much. You're too kind, but because I'm sure you're hungry, that's why. I will leave you with this last slide, which I'm ready, of course, to show you because it's a bit longer. But this is an example of a professional use that the Rijksmuseum has done of a tomography reconstruction of these statues. And they have done, I think it's the first example, but we are now going to follow this example with other, also Italian museums, to use the neutron data, tomography and radiography and diffraction data, to reconstruct this video, which is made professionally. You might notice the difference between this video and the previous one, which were done by researchers. This was really done with a very professional way, and the Rijksmuseum has now put the museum on sale this video together with a book, which means that this very high technological tool can be also address a very simple question to a general public. Thank you very much. I'm ready to answer to your questions.